advanced web application architecture. Actually, it's supposed to be not advanced in the sense that it's going to be complicated. It's supposed to be quite simple, but it's more like it's advanced because most people start with a different approach to web application architecture. So it's more like maybe level 2 or stage 2 of web application architecture or setup. My name is Matthias Noback. I'm generally a PHP developer, but I also do public speaking, workshops. I like to write books every now and then. So lots of side activities there. Our business is about change, and I think you must have noticed that by now. If you're working on a project, there are so many things that will sort of force you to make a change to the code. There may be some issues with the code, like bugs, but most of the time it's really people coming to your desk or your team to ask for changes. And you need to be ready for that change, right? This is an excellent book, by the way, by Ken Beck and Cynthia Andres. Extreme Programming. It's maybe less extreme today, but it's still very relevant. I can definitely recommend it as a reading material to improve yourself as a software developer in general. But embracing change, that is the most important thing to do in your job in every way. And this book explains how you can be ready for change, how you can accommodate for change very quickly. But it means you have to be worried about change in a broader sense, and you have to worry about that to be aware of it. Like what else is happening around you in the real world, in other parts of your company, and inside your code base. So you have to keep track of what's going on. And I find that for many projects that I've encountered in the world, most projects have trouble with keeping up with changes. They have trouble upgrading to the next version of their framework, or they have trouble changing code because they are worried that something is going to break. And a lack of tests usually is an issue there as well. But I think mostly the problem is that things are tied together. Like there is just so many things related to so many other things. There is a complete lack of isolation. So if we think about dealing with change, you have to care about what are the different rates of change in my project, but also in the world around me, and what are the different reasons for things to change. And then you have to prepare for these changes by doing things in your architecture. So first of all, change rate. You could consider like the framework maintainers. You may use a framework. I've heard Laravel is a popular one here. Or maybe you use Symfony or Zend or something like that. But these maintainers, they usually have much more time to fiddle around with their code, and they will regularly bring you updates, like changes, different ways of doing things, new ways of doing things, new features, new syntax. So you have to keep up with that. And they have their own rate of change, which is different from the rate of change that your project requires. So sometimes hard to keep up with that. Then there's the rate of change of business. Your company itself may be changing in a certain pace. Maybe you are experiencing lots of, like you get some insight in the user experience, so you have to incorporate the changes there. But everything is happening there at a different speed, a different rate. And then there are the reasons for change. The framework maintainers, they bring in their changes, so you have to deal with that. So that's one reason for change. And this is mostly in the area of framework integration code. So this is where your application is configured, or where maybe you define some routes or write your web controllers. If something changes there in the framework code, you also have to adapt to that change that is basically outside your own application. If you're making remote service calls, that's another interesting area where you are relying on other people's software, and if something changes there, like the schema of a response, like we saw in the first talk today, like something is going to break. You know, maybe they suddenly start paying or start requesting you to pay for their services, and well, you have to change something about that, or they maybe require some new authentication protocol to be used. So all kinds of reasons for change that are not under your control. You just have to deal with that. And then there's the domain model, which I think is also changing, but for different reasons, right? Because maybe you are discovering something about your domain, you are talking with people in your company, or you're talking with the users, and they also have some influence on how your software is supposed to work. So you have to deal with that. What I find is usually the issue with these kinds of, well, messed up projects is that things that are changing for different reasons and changing at a different rate are still mixed. And so what I usually aim for is to separate the different areas of the application along the lines of what changes for what reason and at what speed. Because if we can keep these things separated, it's much more easier to deal with these separate areas and to respond to these needs for change. So it could be considered a single responsibility for, single responsibility principle for architecture. What changes for the same reason should be grouped together. So this could be the general principle for application design. As a few examples, all the things that are related to your framework that change because of the framework authors have come up with some new thing, they could be in one part of the code base. Then your domain model could be in another part, but maybe all things related to database communication, like some queries or some schema definitions, migrations, everything like that could be in sort of the database area of your application. These are just examples, and I imagine you can think of some other ones for your applications. Funny thing is, there's really only one way of grouping that is actually very important. I mean, you can find groups for like many different kinds of groups for your code, but two groups are very important, I find, which are domain and infrastructure. So these could be considered the main groups. Like, what is your domain about? What is your business domain about? And what kind of code have you written to support that business domain, including all of its activities? This could be your domain model, like some entities maybe, some value objects and how they are related together. These could be your use cases, like what can you do with your application? What kind of data does it expose? And these could be the objects that represent other things you need in order to fulfill the use cases of your application. That could be considered domain, or sometimes called core. Then there is infrastructure, which contains all the framework-specific code. It contains the implementations, like API clients that communicate to systems outside of your own application. It would be the code that is in the web controllers or the command line tools. All of that is to be considered infrastructure. And these are the main groups that will help you structure your application and keep things separated that change for different reasons. So groups, I mentioned groups. These could be considered layers as well. Layering is just a way of grouping things. And then with layers, you can have like rules. What belongs where, which things can talk to which other things. Yeah. So traditionally, we have these layers in a sort of a horizontal diagram style. There's the web framework on top. It accepts the requests. It forwards information and calls to domain logic, the types of things that we saw before. And then it talks at some point to a database maybe. So you could say database integration is another kind of layer. But we can make it even more simpler than that. We can say we have two layers. We have an infrastructure layer and we have a domain layer. In fact, domain is not even really a layer. It's more like the thing that is living inside the core of your application. And then the infrastructure layer is sort of wrapped around it. For two reasons. It's going to protect the domain against bad data or bad things that are happening to it in another way. And on the other side, it's going to make sure that we talk to the external systems in the correct way. But these things are not mixed together. So the domain is pure code. It's describing your concepts in your domain, the relations there, and what you can do with these things. And then surrounding it are implementation details, like how do we support the domain, basically? How do we make it useful in a real world scenario? Then step 2 is to apply ports and adapters, which is a way of looking at applications invented by Alistair Cockburn. Currently his website is down, so that's a bit of a difficult thing if you want to look for more information, but I add some sources at the end of the presentation, so you can look it up later. Ports and adapters is the alias for the hexagonal architecture style for applications. It's not just web applications. In fact, for any kind of application, you can say we have ports and adapters, and I will explain how that works. You start with thinking about who is using our application and what other systems are we using. So in the first case, it could be like the primary actors. Those are the ones that initiate communication with our application. So it's like a user who is interacting with our application using the front end, for instance. And then another primary actor who also initiates communication could be a cron job. So it's just something that tries to speak to our application. And then on the other end, there are the secondary actors, the things that our application needs, that are not inside our application, but in the world outside. So this could be a remote web service that we need to talk to. It could also be a database server. We need to have it in order to do our job. But then knowing what are the possible actors that are using our application and that we are depending on, we should make a distinction between the communication, like what's going on, what is the intention for that communication, and how do we support it using implementation, like just code. As an example, let's say our system is designed to sell tickets to users. So yeah, like the user can buy a ticket. That is basically a description of a use case. What can a user do with our application? And what is their intention when they first reach out to us? Well, they want to buy a ticket, right? And then there's lots of technological details going on in the background in order to support this communication, right? So we of course have a web controller with some action, some services injected, and we may need to get the user from the session and process the form data. All of this is really highly technical stuff, highly detailed stuff, but it's only there in support of that single use case that the user can buy tickets. And this is exactly the distinction. So we have the intention and the implementation. On the other end, we might need to at some point persist the order. So this is again sort of an abstract way of talking about it. We need to remember the order. That's another way of saying persist. Maybe that's what you prefer. We need to remember the order so that when the user comes back, they will still see that order, right? That's important. We need lots of technology on the other end to implement this intention. So we need to have an orders table in the database. We need to have maybe database migration scripts. We need to have that database, in fact, and we need to talk to it using SQL queries. We may use Doctrine DBEL as a library on top of SQL. So lots of technology there. Usually the use of acronyms like MySQL or DBEL is a sign that you're talking about technology. So that's the way you can make the distinction there. Like it's an intention versus the technical implementation of fulfilling that intention. And in ports and adapters, these intentions are called ports. So it's whatever is possible with your application, or whatever your application needs to be possible by means of using other systems. So buying a ticket is a port. I can buy a ticket, or the user can buy a ticket. It's however you'd like to describe that. Another port would be persist and order, right? It's just something that goes out, and well, the core, the domain code, only worries about that this is possible somehow, but the implementation is left to some other part. And this part is called adapters. So every port needs an adapter to do its actual job. I mean, without an adapter, it's just an intention. So we need to have some code supporting that intention. There is an incoming request. It gets processed by the web framework, and before that by the web server and whatever technology is in front of that. And at some point, we are at a place where we can call the inner hexagon, the six-sided polygon, that is our application. And from that moment on, the domain doesn't worry about where does this data come from. Is it an HTTP request, or do we use SOAP, XML, JSON, whatever technology is involved? Is it a cron job that tries to buy a ticket? I don't care. The domain is completely ignorant of that. And then on the other end, of course, it's going to, say, persist the order. It's likely to be an interface if you're an object-oriented programmer. And there will be some code supporting that intention. Like we want to store it, well, we need an SQL adapter for it. So that's the two different things that will describe your application. All the ports represent everything you can do with your application, and the adapters represent how this happens. And this is a very simple idea, yet a very, very powerful idea. Because what are the kinds of things that we can do with that? By definition, being able to separate domain code from infrastructural details increases testability. Because I think maybe you know about unit tests. Like what is a good unit test? A unit test is something that doesn't use a database. It doesn't use network communication at all. It doesn't use the file system. So there's no special preparation needed in order to test that kind of code. This means that the more we can push into the hexagon, into that port stuff, we can say, we can test this using simple unit tests. Or maybe we can combine different units in a sort of a larger scale test, but at least they will be very quick to run. There will be no problems where the database has been misconfigured or an external service suddenly is not available for a couple of seconds. So there is a chance for you to write very reliable tests that are close to the domain, and this also allows you to describe these tests using domain language, pure domain language, without talking about HTML elements, classes, maybe form field names, buttons. You know, all of that technical stuff is left out of the tests for your domain. So that's a big advantage already, I'd say, because making testing easier is a great way to get more people to write tests, right? Then, if you look at the diagram where there's a hexagon and the adapters, you can imagine that the ports, nothing changes about the ports if you would replace one of the adapters. You could say, switch to a different database server if you like. Like the adapter we just discussed is an SQL adapter. It could as well be a MongoDB adapter, right? Just to mention one of the sponsors, right? But you can also just store JSON, if you like JSON, you can just store JSON in a file on disk. And your domain code would not be worried about that. You can just write this new adapter and replace it. I think it's also in the definition of adapter, like you get a sense that you can switch adapters, but the main functionality will be the same. So that's, again, the idea behind ports and adapters. It's even possible, if you can write tests for your domain code and show how the major use cases are implemented correctly, and then like leave out the implementation details to the adapters, you can actually postpone the choices for what adapters am I going to write. And basically, you can postpone the choices for what kind of database am I going to use, what kind of framework am I going to use, do I even need an ORM to map my objects to the database? Is that even a good idea? So postponing these kinds of decisions is quite a radical thing to do. I find that many teams usually start a project like with a sprint 0 and then make a decision, we're going to do this with Symfony, with a MySQL database, we're going to use this and this API like web service. And with this approach, with ports and adapters, you can basically postpone all of that technical stuff. You can start in sprint 0, or basically call it sprint 1. You can just start implementing domain logic and use cases. So that's a great way to get a sense of, do we understand our domain correctly? So it's definitely supporting a domain-driven design approach for software development. But it can also help you make more informed decisions later on when you know what kind of database works really well for your project. Instead of having regrets later on in the project, like, oh, I wish we would have chosen a document database, now it's way too late to do that. Instead, you could have been working for months, like gaining feedback from the system, and then making the right decisions about the database you should choose. And this is true for all kinds of infrastructural details. You can postpone any of it as long as you keep this clear separation in the code. We started with a discussion about change rates and reasons for change. Having these things separated, like domain and infrastructure, as separate elements, allows you to keep up with the rate of change of other people or other teams, other companies. So if you have a framework that wants to change many times a year, like their way of writing a controller or setting up routing or whatever, it should be relatively easy because the way they do things is not all over the place in your code. So it's just limited to that single adapter that is supporting communication with a user. So I find that a way to protect your future, the future of your project, and keep it easy to change with them or with whatever thing happens in the world outside that you need to keep up with. In fact, you could actually just replace your entire framework or decide not to use any framework at all if your application doesn't ask for that. So that's I think that's a very good idea to try. Recently, I've been figuring out again how like just plain PHP works well in so many cases, and all of the added complexity is sometimes really not necessary. So, but that I'll give that to you for thinking about that during the break, right? So here are some useful sources that I think will be worth it to look into. First of all, Alistair Coburn, like I mentioned, his website is down, and I don't think he has a book or something about this topic, but there is a very good talk which has been recorded in Paris, I think 2 years ago, where he was talking about hexagonal architecture. Funny thing is that he usually never talks about it, and apparently now, like after years of after having invented this thing, well, he suddenly talked about it, and so that's an interesting opportunity to learn from him. I'm also working on a book myself about this topic and like the broader context of designing web applications, including how to test different parts of it. This follows more or less how Ned Price and Steve Freeman describe their architectural style in Growing Object-Oriented Software Guided by Tests. An excellent book, very interesting for you to read, I think. And then there's Von Vernon on Implementing Domain-Driven Design. If you're interested in that part about making your domain right, then that's a good book to start with. And if you're interested only in the architecture part, yeah, you could still look up this chapter on architecture. So that's it.